We had full moon on our first launch attempt, and it was pretty full the rest of the time. Made a pretty spectacular evening for us every night. NASA has these cameras, these secret trick cameras that look right through your hair on the back of your head. I noticed that.
This is a pretty ignition sequence. There's the mains lighting. It was not very noisy and very smooth, and you'll see some shots here. You can see the igniters horizontally into the flame. You also see the engines being gimbaled there as a test just prior to liftoff.
Those burned smooth, but boy, I'll tell you, when those solids lit, you really knew that something had hit you. It was a really a very big increase in vibration in the vehicle, driving over, like John said, driving over a real rough road, and that's really just about how it felt. But it sure was a nice, solid push getting off the pad. Roll maneuver was spectacular. Boy, that thing really whips around.
There it is, rolling over. And that was really some kind of ride. And as Joe said, it just seemed like a rattling of the whole spacecraft when the solids were burning.
Wasn't so bad that you couldn't read checklists or read any of the displays or reach any of the switches, but it...
Here's a beautiful view of the Florida coastline. It's taken out in my right window.
Lay your head on your left shoulder is what looks right on this one.
Off we go. This is, there's the roll maneuver. Now this is shown about twice the speed through a little cloud deck. There's the highway going up the east coast of Florida, and you can see both the coastline and the inland waterway.
You know, y'all look super out there with your heads laying on your left shoulder like that.
Notice the sky getting dark. Finally, of course, got to be solid black. And just at the end of this sequence, you're going to see two stars rise right about the center of the horizon there, coming up. I think. I hope.
There they come. Right in the upper right hand. Just barely come. These pictures were taken from our chase planes, and luckily we didn't have to use them down at the Cape to come back in, but they were there ready.
We ought to say a word for the recovery teams that recovered the solid rocket motors out of the ocean. The seas were terribly rough. This is a beautiful view of separation. You can see the three main engines lit, and we're done with separation. Just like Johnny Cripp, the windows were completely enveloped in flame. At any rate, the seas were really rough a few days after the launch, and those teams really did a super job to get the solid rocket motors out of the ocean.
This is the external tank separation at the end of the main engine, Miko. You could see a washer coming out there. This cable that you see flapping around on the right-hand side of the picture is a part of the baggie installation that protects the opening there at the fitting, at the tank fitting, and was really of no consequence, although I think, like Dick and I, when we first saw it, we'd have been a little concerned about the thing flapping around out there, not knowing that it was or was not supposed to be there. You can see the tank tumbling also, and you notice the scorched bottom end of the tank, and as it tumbles around just at the end here, you'll be able to see where the solids were not shielding it. The flame pattern started lapping back up on the side of the tank there.
This is the fun starts here on orbit. Here's a couple of tourists supposed to be working and telling Houston that they are, but really looking out the window and having some fun. This is the area behind the ejection seats. Now we've switched to a view of, with the payload cameras, of the opening of the port payload bay door. There's the arm there stowed in the lower right, and the OSTA experiment in the center of the payload bay. This was at night, so the light you're seeing is reflections from the lights that were on inside the payload bay, and there's the light shafting across the Ohms pod and up the vertical stabilizer.
Center of the payload bay here is the OSTA pallet, and in the upper center, moving to the upper center of the picture now, is the Sur-A antenna, one of the major experiments on the OSTA pallet.
Sir A is a synthetic aperture radar. This was really a beautiful sight, seeing the experiments in the payload bay and then looking up there and seeing the Earth.
Just about the entire duration of the flight, we were oriented. Well, I'll dictate about that.
I don't know who did that.
Kind of a quick walkthrough from the elbow camera on the arm. If you look up there in the upper left-hand corner, you can see the camera looking back down into the payload bay, and that's where that picture was taken from. And
I think this was one of the TV pictures that came down live that was pretty, but we had the best seat. The wireless mic was a resounding success. You can see it strapped on my right thigh there, and there I'm using the push-to-talk button to talk to Sally Wright, I think, who was running the RMS or talking to me from the control center during RMS operations. And as Joe said, this is a kind of a short tour of the orbiter from the elbow camera on the RMS. RMS was really smooth. In all the modes we tested it was just no surprises from the simulator, and we did a maneuver. Both of us did a maneuver up to the grapple fixture. As you know, we did not do a grapple on this flight. The STS-2 crew is going to do that, but I predict that they are going to like the way that the remote manipulator system maneuvers in space. Just like all the people that have gone before us, we found that one of the big problems was housekeeping and managing books, and pencils would float by, and you'd go down the middeck, and there'd be a camera out in the middle, or anything that we hadn't tucked away we'd find quickly.
I think Dick is getting ready to cradle the arm now. In this sequence, you'll see how he straightens the arm out, get it into position to bring it down into to cradle it. One of the cradle sequences that came down live, as a matter of fact, we have a short clip of it here, tends to make you think that the arm is kind of goosey, and I'll show it to you here, but actually it's just that was not the primary mode, and it was one of the tests that we did. Actually, it was very, very smooth. And also you can see the saddles that the arm sits in there in this picture. They actually roll out from at the first of the flight, and they were kind of rough when we tested them down at the Cape, but they were very smooth in zero-G. This is the view that I was talking about. This is what we call the direct mode of the RMS. But the single mode is the mode that eventually will be used operationally, and this just proves that there are alternate ways to cradle. Because of the shortened mission, Dick ended up doing just about all the RMS work, and the only thing I was doing there was running cameras and making them go to the right places to get the right views of the RMS operation. We didn't have much time during the mission to get planned television and planned photography inside the spacecraft. As a matter of fact, of the 850 pictures of the Earth that we took, I'm sure that 800 of them were taken after we put Houston to bed. But one thing we did do one night was, it's all in how you look at it. One thing we did do was Joe set up a TV camera down in the middeck, and we just let it run for a while we ate our meal and did some things, and we just
Thought we'd show you how much fun it is in zero-G, and this is easy. I found in this particular scene that I was just tall enough so that my feet could touch the ceiling and my head could just touch that water tank, and I could stay there all day, upside down or right side up, whichever. Notice the checklist out there in the middle of the mid-deck. Now this is the part that sure beats working for a living, I'll tell you. Just like a couple of porpoises or something swimming around.
We'd had the good fortune to do some homework. Well, here's one of the experiments, the nighttime optical survey of lightning that was meant to study lightning patterns and from orbit to look at different patterns, not only from cloud to cloud, but within the cloud itself. And from the meteorology standpoint, there are just some spectacular clouds to be seen once you realize what's happening down there. Those of you out at Edwards were watching, you notice these white puffs coming out. We were not attempting to write Burma shave, although Dick and I've talked about it beforehand. These are exhaust plumes from the reaction control jets, the yaw jets, responding to the inputs of some of the latter program test inputs, the data maneuvers that we were flying to determine the derivatives of the vehicle, the lateral directional derivatives of the vehicle. Incidentally, the airplane, throughout the entire entry and landing phase, the best we could tell, was just as solid as a rock. It had no overshoot, no oscillations that we feared we might see in some areas. Just a very steady, solid vehicle all the way down. Final approach, you can see the chase plane out to the side there. We did switch runways. We were originally going to land on runway 15 and take advantage of a crosswind so that we could evaluate what the crosswind characteristics of the orbiter were as we landed. The winds actually picked up a little more than what we had planned to try on at least our first crosswind attempt, so we switched back around to runway 23 at Edwards and landed essentially into the wind with practically no crosswind component, with a pretty healthy headwind component.
Columbia has very little tile damage after this flight, which we think is really marvelous for a vehicle this size and on only the second flight. That's not going to be a major problem in the turnaround. My main chore during the landing was to lower the landing gear, which incidentally went down right on time.
And all the way.
And all the way. There's a chase which did a super job.
We rolled out about 7,000 feet. We did do a braking test on rollout, which was really our final flight test objective, if you will. And the braking test went well. We, I think, demonstrated. Of course, we had the headwind, so we stopped shorter than we would have with no wind. But we did stop the vehicle in 7,000 feet of ground roll. I think demonstrating that certainly the bird is capable of landing on our 15,000 feet and probably our 10,000-foot designated runways with no problem. And I say we did light braking too. We certainly didn't go to maximum braking on the maximum application on the brakes. We maintained between 7 and 8 feet a second deceleration rate.
When we landed, I felt perfectly normal except for the 350-pound person sitting on my shoulders. Seriously, that was the only sensation that I really had when we got back on Earth, was just really felt heavy, but after we walked around the bird here for 5 minutes, that went away, and it was then we were back in 1G. I told Dr. Kraft I thought that the only thing that's really bad about the orbiter is when you put 1G in it.